again, day one at CAMX in San Diego, and I have Yannick Vilma, right,
Right.
of 90 Labs. You can find him 90labs.com. Yannick's been on the he's been on the podcast before. I think you were back at CAMX maybe a couple of CAMXs ago. So we had you on. You can see their website. Good to see you again.
Thank you.
Yeah,
Good to
thanks
see
for
you,
stopping
Jonathan.
by. So let's get started. Tell us a little bit about the company. You're based out of Switzerland.
Yeah, correct. So the company is a spin-off of ETH Zurich, so
Yeah.
from the technical university. That's why we are still mainly based there. So main team, 40 people roundabout in Zurich, downtown.
Mm-hmm.
So we have facility, offices, manufacturing facility. And we have also a small site here in Lowell, north of Boston.
Okay. How big is your team there?
Handful of people.
Yeah.
So
Pretty
more,
cool.
technical, commercial people supporting projects in the US.
Yeah. So you're working with OEM manufacturers?
Basically, we are selling the technology, both the software and
Yes.
the machines. But to do so, we have to understand the pains and opportunities at OEM level,
Mhm.
the different industries we are targeting.
Yes.
And then we go to their suppliers, obviously, so that they can integrate technology.
I see. So what are any particular industries right now?
Yeah, three core industries, obviously, starting with Switzerland, very cliche,
Mhm.
luxury, so
Mhm.
luxury watches.
Oh, yeah.
That's where we already have products in the market.
Interesting.
Yeah. And then we go into sports cycling mainly.
Mhm.
Also fast cycles. So you have a yearly season where there are launches, so good opportunities to bring in composite parts anyhow. And the third one, longer term, obviously takes longer time. Aerospace interiors, so cabin parts.
Okay.
So that's more on the aerospace side, obviously.
Okay. And talk to us. I've got your website pulled up. Your steps for scaling production for companies that come to you, and they've got a project on hand that they want to work with.
Yeah. So typically when company approach us, they have two main challenges. Either they want to lighten their parts, so they have
Right.
aluminum, titanium parts, and they want to go composite,
Sure.
or they have composite thermoset and they want to look into thermoplastics for recycling reasons, for scaling in reasons. And there it always starts the same. We first do a feasibility study, just check up, do we bring an added value on the technical side?
Yeah.
And what about the economics? So we do cost modeling just to show, are we on par with expectations? And then from there on, we go into designing, redesigning parts.
Mm-hmm.
First in the design software, so we have a software part of our product.
Right.
Then we can simulate, validate digitally, and once if that's validated, we can move into the physical part of the project, which involves, of course, a bit more resources,
of course,
but where you can then test real parts. Yeah.
What typically, what is the time frame from the time that you get the project, the digital file, the 3D model, to the time that you're able to hopefully take this to a commercial process? What does that look like typically?
Yeah, typically I would say count around about 6 months.
6 months, okay.
Yeah. Of course, don't count 6 months for industrialization of parts for aerospace, because there is certification and so on. But I would say for watches, we have made some projects from first contact to part in the market in 8 months. And then from there on, it's really depending also on the launch seasonality. Yeah, around about 6 months. Yeah. Definitely less than a year.
You said the watches. Are these cases? Is this something? Is this one?
Yeah, this is one I'm here.
Let's show that.
Here, so maybe you can show it. You can zoom in. It's watch cases, so it's more the macro parts of the watch, obviously.
Oh yeah.
So watch cases, bezels, dials, those pretty visual parts. So very different, I would say, from aerospace, because you have this aesthetic component of the development. But there is also great functionalities. It seems like, okay, it's just a nice luxury part, but they have to go very deep into water. They have to have air and water tightness.
Yeah.
And then
it's interesting. Solid. That feels like really solid. It feels like a luxury piece.
Yeah,
it's heavy.
it needs to sustain whatever you do with the watch.
So. Right. So it's unbreakable, correct?
Nothing is unbreakable, but I would say if you break the watch, you might have hurt yourself.
Oh,
also.
Okay. They have to put some effort into it, right?
Correct.
And I mentioned your website, Yannick, 90labs.com. Is that the best place to start?
I mean, typically, if you go through the website, you will. I will be the first reading the message, even.
Yeah.
And then I will, of course, share that with the colleagues, which the best to speak about a specific question.
Mm-hmm.
Of course, you can reach us through LinkedIn, and I mean, I'm pretty visible on this platform, so I get also requests directly per phone. But,
what about I've got the additive fusion technology. Just give us a highlight.
Yeah, I mean, why it's called additive, basically, I mean, the first step is obviously the software, but then once we go physical, we have two machines. We have developed an additive manufacturing machine, let's say. It's just to automate the placement of the material very accurately and without waste. That's the interesting part of this additive manufacturing step. We could call it micro AFP because we use very thin tapes, very narrow tapes.
Mm-hmm.
And then we have a second step because I would say it's a preforming step.
Okay.
So it's not finally consolidated. All the properties we want in high performance applications are not reached. And then we go into a compression molding or injection molding step. Of course, you go back with tooling, but for the sake of doing high volumes.
Yeah. Yeah. So a very cost efficient process. You said you're not wasting material on the wrong areas.
Yeah. So usually from what we deposit to the final parts, there is no waste in the process.
Yeah.
In terms of material. And that's pretty unique when you consider how most of the parts in composites are done today.
Yeah.
And that's a way also to compete versus metals, because we know the efforts going into a carbon fiber in terms of energy. So we don't want to waste it. So we really want to place it where it's necessary and not everywhere.
Right.
And we don't want to have cutouts or waste streams.
Yeah. Lastly, how's the show been so far? Good?
I mean, for me, the show started yesterday, so I was already touring
you were
a
here,
bit when they were building up and meeting, of course,
because you got community. You got the highly rated badge, so you have access to everything, right?
No, actually, I'm organizing a panel tomorrow.
Okay.
At 9 a.m. We have something about additive manufacturing. What about the buzz? Is it really delivering?
Yeah.
So we do that with Ginger from Composite World as a moderator and some cool kids around.
That's good. Yeah. Yeah, that's a big. I'm glad you mentioned that, because that's a big question. A lot of people have. Is additive manufacturing, is it really delivering? All of what we read and everything that we've looked at, that people have said, oh, this is going to deliver all sorts of opportunities, and I think they have, but I think maybe a little slower pace than what we've expected. Or what's your opinion on that?
Yeah, I mean, my opinion is first, it's a matter of definition and of expectation. So obviously, this 3D printing market, typical overpromised and under-delivered.
Is it now? Was it from an investor standpoint? Was it people trying to, impress, over-impress, or over-promise the investors, or what?
Yeah, I mean, I'm sure. I mean, as with all new technologies, there is a hype, and you need to be confronted with a reality. Nothing better than having customers challenging your solutions.
Absolutely.
And then I would say, additive manufacturing, composites has always been additive. It's
of course
layer by layer, stacking, and then consolidating or whatever. So what I like is now seeing it's not only additive manufacturing. There is a lot of different technologies and stacks in these technologies which aggregate nicely.
Yeah.
And we see products out there being scaled based on this technology, but we are far away from there is a black box, you click on a button and the car is coming out ready to drive.
Yeah.
So I guess that's a difference in maturing.
People have to temper their expectations with the technology and understanding. Right. I mean, they have to.
It's not magic. I mean, we know it's tough.
No, it's science. I mean, or it's engineering, and yeah, I mean, you have to understand that I think you said it right. It's not magic. So
yeah, it's hard work, and that's why we are here, meeting the community and getting great things out of it.
So 9 a.m. tomorrow.
Room 2.
Room 2. Okay. And what's the title again?
It's additive manufacturing. Is there a reality behind the buzz?
Okay. Yeah, it's good. That's an interesting. That's an interesting topic.
So different technologies in different markets. Yeah. Some technological overlaps also, just to get cool debates. Yeah.
If people want to reach out to you, can you throw out your email?
Sure. Yeah, it's Yannick at 90labs.com, or reach out on LinkedIn. I'm easy to find.
Yeah.
You can even find my phone number on LinkedIn. So
Yannick, you can see how it's spelled because it's streaming down at the bottom. 90labs, 90labs.com. So, Yannick, it's always good to catch up with
Thank you,
I
Jonathan.
appreciate you coming by, and I want to encourage our listeners to check them out at 90 Labs. Looks like a brand new, last time I checked, brand new website. It looks incredible. So good job with your team.
Thank you.
Yeah, absolutely. Thanks again.
Talk
Enjoy
to
the
you
show.
soon.
Yeah, absolutely. Thank you.
Cheers.